We'll start with the definition. I'm going to see if you can figure out the power rule. All right, so if I calculate the derivative of x squared, does anybody have the definition memorized yet?
Oh wait,
The H one.
Oh,
f of a
plus
x
a minus f of a over h.
Okay, you can put a in there if you want. If you put a in there, it means there's a number. We're just keeping x. We're not going to put a number in. Okay, so what am I going to write out? So what's f of x plus h?
Squared plus h.
Okay. Yep. All right, at this point, for AP purposes, this is what you will see on a problem. Okay, they will say, calculate that limit. Okay. So you recognize it as the limit definition. Then you will, what you're going to do is know that the function is x squared, right? Because you can see the function is x squared. And you're going to use the power rule to calculate the derivative, which I'm going to show you here in a sec. Okay. So you don't have to do the algebra if you don't want to. So we have x squared plus 2xh's plus h squared.
Yeah.
Right?
X squared is 12.
Right.
And then h is 2x.
So we have h times 2x plus h over h. What's the answer? If I plug 0 in for h. 2x. Okay, there's the derivative. So I would write f prime of x equals 2x. Do you see a relationship between the original? I plug 0 in. Okay, I'm going fast, sorry. Throttle down.
Please.
Lift off the gas. Yeah, okay.
Wait, slope is 2x?
So yeah, how would I, to avoid this,
Wait, Mr. Arthur.
how can I go from here to here?
You put the exponent in the
Okay.
value. Mr. Arthur.
And the exponent just disappears?
Yep. Becomes mathematic.
What's the exponent here?
To the 1. For that,
So how do those two relate?
they're inverted. They're cousins.
This is not family business.
They won't know.
How do I get from 2 to 1?
You subtract.
Subtract
1.
1. That's it. All right. So let me give you.
You subtract however many it takes to get to x.
What is the derivative of x cubed?
Yeah.
3x squared.
What? But Mr. Arthur, why isn't it when you take out the h to factor? Why isn't it 1? 2x plus 1.
Because that's where I was thinking, because that you have.
Oh, that should be h squared. I
Okay.
didn't
Oh,
write it
okay.
out right.
Okay, there we go.
Sorry. Oh yeah, so that's the power rule. Ta-da! Woo. You just calculated the derivative.
So wait.
Really, literally, yeah.
Question. So you take the power and put it in front of
Yeah.
the x and just
The
subtract
exponent
one of the exponent?
goes in front, and you subtract 1.
Okay.
Okay?
I can do that.
Yes, we can do that. That's why I told you it was gonna be easier today.
Why can't we learn that first?
Every year I get the same question.
Yeah, why can't you have to learn? You have to learn
Wait.
how to walk before you run.
I like to
No,
secret.
I don't.
Sometimes you need to understand purpose before you can act on something.
No,
This is
So
a
the
good
water for your
advice for
phone.
life.
The price is right.
Right?
Okay, so in general, and I would be a bad math teacher if I didn't show you this. If f of x is x to some power of n, okay, n is a real number. It's just a number, right?
Yeah. Yeah.
The derivative is
And next
n
to the
x
n minus
to
one.
the n minus 1.
Ah,
What does that say?
in general?
n is, so here's the power, right?
Yeah.
X to the n is a real number.
Oh,
So the n can be any number. This is just a generalization of the power rule.
I'm not sure that's in.
Bring the exponent down, right? And subtract 1. Same deal. I would be a bad calculus teacher if I didn't educate you on this stuff.
Just got one.
So if it's not a real number, then you can't do this. What's hard? Right, Mr. Arthur?
What?
Negatives are not real numbers.
Negatives are real numbers, yeah. Negatives are not natural
That's just the
numbers.
inverse, right? That's 1 over x squared.
Yeah, that's not the inverse.
So
It's the
1 over
reciprocal.
x.
Would it be negative 2
But,
x or negative 3?
okay, so y prime is negative 2x to the,
Negative 1.
Wait, no, it'd be negative 30.
thank you. You have to be careful of those, okay?
No, just follow the formula, guys. I thought it was so extra.
Just don't make it hard.
Victor, you okay there?
No.
She's yelling at people.
Evelyn, I can't hear you.
I'm not understanding why you put what
You okay, so bring the exponent out front and subtract 1. Negative 2 minus 1. Right, yeah.
Does this work if there's something other than
Be aware,
what happens if there's something already in front of that? Oh my
the, so
I
like
would
if
just
it's,
use add.
we're getting there, calm down. Be aware that this can also be written like that, right?
yeah.
Those are the same thing. So if you see something like this, you need to rewrite it as an exponent,
Like that, okay.
a negative exponent, and then you can use the power rule. Okay.
Like, so you don't have to worry about doing the inverse. Oh, that's good.
And you can also rewrite the derivative if you need to. There will be a lot of times where I tell you that this is what I want to happen, because it shows us horizontal, vertical tangent lines, discontinuities, makes it very obvious. Where is this not continuous?
0.
X equals 0, right? So, okay. Let's talk about, oh, you asked, yes. There are, there are a couple different ways I can write the derivative.
Okay.
What's the derivative?
2, 3, x.
Okay. 2, bring the 4 down, so that's when you multiply those two.
Times 4.
So that'd be 8x to the third.
X,
X to the third.
yeah,
Lord God.
that would be these. Okay. All right, so yeah, if there's a number in front, a constant, Just multiply. Okay. I can also write this. Okay, there are three ways we can write derivative. Okay. We've seen f prime of x, right? You see y prime? Okay, the other way is derivative of y with respect to x. That's how this is said. Okay. And it will have benefits. This notation will be beneficial. We just need to get used to seeing it. Derivative of y with respect to x.
What will respect to?
Huh?
Why do you say respect with respect to x?
Because we're calculating the derivative of the function of x.
Is it like referring to it?
Yeah, you're referring to x, basically.
Okay.
Okay, so dy dx is still 8x cubed. Same answer, you just, different way to write it. Okay.
Give a healthy respect for them.
So then would that?
With all due respect, right?
So then if we were using f of x, would it be df of x over d of
It
x?
could be, yes, but I would write f prime.
Just in that case, you just write.
But you could write df over dx. Yeah. Okay, you can also see this as calculate. There's another way to ask the same question. So calculate the derivative with respect to x of that.
So 12x squared.
This is where we're going to throw an equal sign up, and there's your answer.
Wait, what?
Okay.
I like the answer.
So you're going to have to navigate f prime, right? So we have f of x and f prime of x. We have y, and we can write y prime, right? Y, we can write dy dx. And then d over dx just means to calculate the answer, right? I don't think there's one other, but I don't think it shows up in our book, to be honest with you. Okay.
What do you mean by just to answer?
Oh, calculate d over dx. Here's your answer.
It's just, you don't need to do anything,
No.
it's just straight to the answer? Okay.
Yeah, these are just different ways to write the same thing.
So f next means the same thing as
F is a function, f prime is a derivative, right? So we have function, derivative.
I might not overcomplicate homework for once. I sent my silver for error.
There is definitely going to be.
Here's a question you're going to be asked. Find the points on the graph of
Did you really not?
One.
Hey, we go back to the next slide.
yeah,
I just need to write something down.
sure.
A lot of writing.
Yeah.
Are we going to have to like replicate this on our homework?
That's usually what we do to practice, right?
Dang it.
No, you did.
Well, what?
No. Oh, you capitalized it. You funny.
Dang it, you caught me. I knew it. I wrote it out and I was like, they're not going to see it. And I just kind of busted by it. You got me.
So what does that mean?
I thought about kind of doing math, but
How much
oh well.
is that what
Yeah, you got me. That's the one time this year that'll happen.
For now.
I owe you. Okay. I think I tried to pass it by. You caught me.
So what's this mean?
So what's the price? Yeah, I mean, like, now.
I don't know. I have to think of one now. I've never had to think of one.
I never thought.
Okay, we have just a couple minutes.
You mean I.
No.
Find the points on the graph of this function. I'm just going to write it better. Where the tangent line is horizontal.
No, he just put the F and X in the front.
Oh, okay.
It's a t, so f is a function of t. F of x, whatever. Okay. What's the slope of a horizontal line?
Gonna be
1. There's 0.
0.
Oh, yeah.
Okay.
I was like, one. Montaigne.
So if I want the tangent line to have slope 0,
Right.
what do I need to do to this? No, that gives you the zeros of the function.
Set it to infinity?
The limit.
Set the derivative equal to 0,
Okay.
right? Because that's where we get tangent line slope.
Okay.
So what's the derivative of f?
3t squared.
Keep going.
Minus 12t.
Minus 12.
Minus 12 plus 4.
That's it. Okay. What's the exponent here?
1.
So bring the 1 down.
Oh, so
Oh.
that takes away t.
T to the 0 is
0.
1. So there's no t anymore.
12 plus 4.
And this is a constant.
If there is no heat, just
It's a loner. Bye-bye.
Oh, so to do it.
This is actually a class where we eject loners.
just take it away.
Oh, plus.
It's a constant. The derivative of a constant is 0.
Okay,
Now what do I set this equal to?
0. So subtract. So add 12 over, right? So divide by 3 and then take the square root.
Okay, I have to write this down.
4.
Slow down, please. Please.
No, Calvin.
Have mercy, Mr. Arthur.
I am a very merciful teacher. You know that.
So it's gonna be 2.
Yeah, plus or minus 3.
I've never understood math so
Why can we not?
I think the last
study
time
this, like,
math was
in
this clear was
four?
like 6th grade.
Right, so this is a cubic, right? Okay, do you understand the math here?
Because
Yeah?
Okay, no, hold on. If you or add 12 divided by 3. I'm still trying to figure that. So that's 1.
Add 12, divide by 3. Oh, we have time. Jason.
So you just get rid of that 4?
Yeah, the 4 is a constant.
Reject it.
The derivative of any constant is 0.
Yeah.
Did you put it back in?
Okay, so why is the other
No.
Why did you just 4 out there? Because the derivative of the constant is 0.
Okay, let me do this algebra-like.
Thank you.
Right, add 12. Now divide by. What is that?
T.
Now what? Square root, right? Positive or negative 2 is t.
Derivatives. Well, yeah, and then the derivative of the constant is 0. Because I can see that.
Get like how we
Right here. And then it's a 12.
This is a constant. There's no t,
1.
right? No variable. The derivative of a constant is 0.
Not, yeah, actual negative 12. Okay.
That's,
Like,
it just accepted as fact.
so it's negative 12 times
Okay.
t squared.
What does this give us?
So that 1 squared will be.
This is a cubic, right?
Yeah.
The cubic will look like this, ish.
Okay, so, okay.
So this tells me that I have a horizontal tangent line at -2 and positive 2.
Whoa.
What are those called?
Derivative.
Local,
Points, local points.
local,
Local minimum.
local min and max. Now that's chapter 4, okay? But derivatives start to give us very useful information very quickly.
Yeah.
Okay.
This angers me that I didn't see the pattern.
Yeah, we are gonna get back to that weird.
Most people do.
It's like.
Okay, last thing, and I'm gonna be done. The reason I show you this today is because it's really easy. The power rule, you know?
Yeah.
The derivative of the function e to the x.
X to the E.
No. Okay, it's an exponential, so if there's an x in here, we don't use the power rule.
Oh.
This is just a fact that you need to accept because
Always
it's really
E to
easy.
the X. Okay, cool.
The derivative of e to the x is
Always E to the X.
Yeah.
So if there's
I
a
agree.
E of X in any problem, it's just E to the X.
That's it.
Why?
That makes sense.
Accept
Do you really want me to go into that?
I kind of do.
Yes.
I'm not gonna. Okay,
I'm gonna write a function.
here's your,
2, 7, 8, 3.5.
So will we be able to do most of this?
well, I hope so.
It was A, yeah.
This is to tomorrow then?
Yeah.
Oh, man.
Tomorrow we take a look at a different derivative graphs. So today we did derivative functions. Tomorrow we look at derivative graphs.
Oh, okay.
Okay.
The homework's just over this first part.
I'm gonna drop a little bit of the spiraling.
Thank you.
I'm not going to bed tonight.
There you go.
Planning on it?
Just going backwards, forwards.
These are those algebra problems most likely. So
Okay, so that was good.
have a nice day. Most of the derivatives are pretty fast. So yeah, it looks like a lot, but it's really not that bad.
Please negative cases. Nope. Right the opposite. Yeah.
No.
See, what is the opposite of sweet? Is the opposite of sweet sour? Is the opposite of sweet tart? Or like, or not sweet, not tart, bitter.
Even though
Opposite of sweet is bitter. So what's the opposite of sour?
Thank you.